All right, next video is going to be on volume of pyramids. Previous video we did surface area where we focused on the outside. This time we're going to go on the inside of the pyramids. Now, if I put a square base pyramid inside of a rectangular prism, or a box if you will, in terms of volume or space, which one has more volume? And you might think initially that this is some sort of trick question. You also need to know that the true height of the box is the same as the true height of the pyramid. And I would hope that inevitably you would go, well, the box has more volume, right? Because there's more space that I could add inside this box, even with the pyramid inside of there, right? So the prism, the box, is bigger than the volume of the pyramid. But the question is now, well, how much bigger is the volume of the box? Or how much smaller is the volume of the pyramid? Now, normally I would do this with you in class. I would do a little demonstration for you. But since we're not in class, I cannot easily demonstrate that to you. So what I would have shown you is that I had a rectangular prism, basically a cube, and I have a pyramid that has the same square base, and they both have the same height to them, and I have a bunch of coffee grounds. Okay, and this could be sand, this could be water, this could be anything. Okay, and so what I would show you is that it would take 3 scoops of coffee grounds of a pyramid, and I could dump it, each of those 3 pyramids worth, into this box, and it would fill it all the way up to the top. Now, initially, you might think, well, I think maybe only 2 pyramids could fit inside that box, but it actually ends up being 3, believe it or not. And I remember whenever I was first in high school geometry, when my teacher asked me, well, how many pyramids worth of volume do you think can fit inside the box? And pretty much the whole class was like, well, obviously it's probably 2, right? And then we found out we were wrong, that it's actually 3. So the way I want you to think about this is, first we would say, well, it takes 3 pyramids worth of volume to equal that of a prism, of a rectangular prism, or a box, if you will, or a cube in this case, since we're doing square-based stuff here. And so we're going to flip this around here. Instead of saying that the prism, the box, is 3 pyramids, we're going to flip it around and say, well, a pyramid is really 1/3 of the box, right? Because it took 3 pyramids to make the whole prism itself. Now, the volume of a prism is something that I am sure you guys have covered way, way back when. I don't even know. Um, Man, I don't know, 5th, 6th grade maybe, when you first start talking about volume being like length times width times height, right? When you guys first did area, it was just length times width. And then when you bumped it up to volume, you went length times width times height. We're basically saying length times width times height here. But the volume of a prism, the general form of it, is you're always going to find the area of the base. And notice I have capital B base. And what shape is our capital B base in all of these pyramids? Well, they're going to be squares. So we got to find the area of a square. We're still finding the area of a square base like what we did with surface area. But now we're going to multiply that by the height. So the area of the square base is kind of like saying length times width. And then here we're throwing in volume and saying times height. But we then have to take 1/3 of that length times width times height to figure out how much volume just one pyramid is. Okay? So the main idea, the main formula we're going to be using here is 1/3 times, there should be a little times multiplication dot in there, 1/3 times the area of our square base, and again, it'll always still be a square base, times the real height of the pyramid. Now notice I have that as a capital H, so I really mean the real height of the pyramid. All right, now I always assumed that you all would know how to draw pyramids, and I found out over the years you guys suck, to be honest with you, at drawing pyramids. Okay, so I'm going to show you a quick, easy way that you can draw a pyramid and make it look like a legitimate pyramid out of a textbook. Okay, so the first thing you need to do is draw a really skinny, a very not very tall and fat parallelogram. Ooh, a parallelogram. What did a parallelogram look like? So parallelogram, something like this. You could draw it like this, which is the way I'll kind of look at it. But basically, I want you to draw something that looks like um, basically the state of Tennessee. All right, so something like this, right? Doesn't that kind of look like Tennessee if you know your geography? All right, and then once you draw Tennessee roughly, so basically a parallelogram was a leaning over rectangle here. It lost its 90-degree angles. Put a little dot roughly where you believe the center of the parallelogram is. And from that center, go up a certain amount. And how far do you need to go up? I don't know. Just go up enough. Okay? Put a little dot up here, again, directly above it somewhere. And then what you're going to do, and I know I get to cheat here and use straight line tools and everything that you guys don't have, but connect that dot up here to each of the four corners of your parallelogram. And then there's your pyramid. Okay? Now, it takes a lot of practice to draw these, I mean, by hand, by how I'm asking you guys to draw them, right? So your pyramids don't have to be meticulous. For the most part, I'm going to draw the pyramids out for you, or they're going to be problems in a book or in a worksheet. Okay? But just for future reference, someone's like got a gun to your head and they're like, "Hey, draw me a pyramid." You're like, "Hey, well, thank goodness my geometry teacher told me how to do that." There you go. All right, so we need to find the volume of a pyramid with a base edge of 8 centimeters. So that means the base edge of our square. So this is 8, this is 8, this side that's over here is 8, this side that's back here is 8. But really, I'm really only going to put these two front base edges of 8, okay? And it's got a height of 15. What has a height of 15? The pyramid has a height of 15. So that means we get to start at the peak and drop straight down to that center point that we made in the middle of Tennessee. So, I don't know, Nashville. So we'll say here's the actual height, which is 15. And if you want to put lowercase b base down here, then there's our pyramid fully labeled. So now to the volume. Volume equals, and this is the part that people always forget, it's this 1/3 part. So the volume is 1/3 area of the base, and here I'll even go back. It's the area of the square base, which will make it even easier, times the actual height of the pyramid. And we have all of those numbers. Okay, so volume equals 1/3. The area of the square base, well, that's an 8 by 8 square, 8 times 8. And then we're going to multiply that by the height of the pyramid, which is 15. Now, keep in mind, all of this is really multiplication. 1/3 times 8 times 8 times 15. And I'll be honest with you, I'm not that great with those types of numbers on my head. So let's see. 8 times 8 times 15. And then multiplying by 1/3 is the same thing as dividing by 3 in the end. So 320. All of that comes out to be 320. And my units are in centimeters. And volume is always going to be cubic units. Centimeters cubed. And so there's an easier example. Now again, what video wouldn't be complete without a little bit tougher example? So here's our second and final example. Again, first we need to start off with a pyramid. So let's practice drawing a pyramid again. Let's get the state of Tennessee out here. And then let's find the center of Tennessee. There's Nashville. And then go directly above Nashville and put a point up there somewhere. And then connect together to the best of your ability that point up there with our four corners of Tennessee. And there's a quick, easy way to make a pyramid. Okay, so now it says it has a base edge of 10 feet. So this base edge down here on the square is 10. This base edge over here is 10. We already know what the area of the square base is going to be. It's going to be 100, right? 10 times 10. Except that one grew a little tail down there. There we go. All right. Now, the 13 that I gave is not the actual height, and we need the actual height. So I'm going to go ahead and draw in, here's the actual height, and I'm going to label it with a capital H, but I don't know what that number is. I need to label and draw in the slant height. Now the slant height, remember, it started at the same place as the real height, up top in the peak, but it slid down the middle of one of our triangular faces. So just draw this in to the best of your ability, going all the way down here, and that slant height is 13. Now, if you remember from our previous video, what we ended up doing next was connecting the bottom of the real height to the bottom of the slant height. So connect those 2 points together, and now we have made a right triangle that's standing up inside this pyramid. And the only other thing we really need to discuss, and here, if you want, draw on a right angle, there's always going to be the right angle here at the bottom of the real height, is how long is this piece that we just drew in here. And if you remember, this is going to represent half of the actual base length. So if the base length is 10, then half of that, this is going to be 5. All right, so now we can do the Pythagorean theorem. So again, I'll do it. Should I do it over here? I'll do it over here, do it over here, do it over here. We'll do it right here. So c squared, wow, that's a really rough square. Let's try that over again. C squared equals a squared plus b squared. Now, the c side, notice, is the slant height. We know that, 13. So this will be 13 squared equals, and then the a and the b, it really didn't matter. But the a and the b is going to be the h and the 5. So maybe I call the h the a. So I've got h squared plus b squared will be the 5 squared. So 13 squared is 169 equals h squared, don't know what that is yet, plus 5 squared is 25. And so now algebraically, I need to subtract this 25 over to the 169. And so now 169 minus 25 is 144. And that's equal to the height squared. So the final thing I need to do is square root both sides to get rid of the square on the h. And the square root of 144 is exactly 12. So there's the actual height that we need for the volume. Okay? So now we can actually find the volume. So let me just move that up there. Let me clear this out of the way. And I'll tell you what, let me move this guy down. And so we can do our volume work. So volume of a pyramid is 1/3 times, remember it's the area of the, in this case, square base, times the actual height of the pyramid. So the square base, nope, I don't want that parenthesis yet. The square base was 10 by 10. Remember we said at the very beginning of the problem that it was going to be 100 times the actual height, which we had to figure out with the Pythagorean theorem, which is 12. All right, so then all of that multiplied out here, and here's some mental math that we could do here. 1/3 of 12, remember all of this is multiplication, so I can rearrange the order of the multiplication any way I want to. 1/3 of 12 is 4, and remember we said 10 times 10 was 100, so 4 times 100 should altogether give us 400. And shoot, I lost my units. They're gone. What was the problem? Oh, in feet. Okay. They were hiding up there. Oh, let's try this again. Best fit. There we go. So 400 feet. Volume, always cubic units, so feet cubed. All right, and that's all for volume of pyramids.